those at Toys R Us.
Sure.
And they're clearancing them.
Oh. How much?
Oh, you got his attention
much?
now.
$10.
$10. Okay.
And I was able to do a little bit of searching about them on my cell phone at the store, and found out that they actually publish. They have a little document that describes the protocol. So they've kind of opened it up. They didn't have to, but that was kind of cool. And then later I found out that they already have Arduino libraries to talk to it. So if you, at first I thought it was going to be
Like a toy?
pretty cool. So I bought enough of them to build a quadruped robot with 3 degrees of freedom per leg. So it's 12 of them. But on further investigating, it turns out there may be a slight problem. The speed is extremely slow. It comes out to about 2,400 bits per second. You can only chain, and they're smart, they're digital, so you can daisy chain them, but you can only daisy chain up to 4 on any one chain, which is not a big deal, because each leg is going to have 3, so 4 chains of 3.
2,400 is not bad, really. If you're going to be just sending speed to them?
Yes.
Okay.
But the packet is set up so that it's a 6-byte packet. The first byte is just telling them that this is a packet.
Get ready for more.
I think it's FFX.
Mm-hmm.
See what you got here. And then the next 4 bytes are the positions for the up to maximum 4 servos on the chain.
Right.
And then a checksum byte. So that takes about 24 milliseconds to send that. And then each servo sends back the position. It has feedback, so it tells you where it is, but only one of the 4 respond on each packet. So you get the position feedback at 1/4 the speed that you're updating the positions, essentially. So the whole thing takes like 32, 33 milliseconds.
That's very fast. I mean,
not for a legged robot. It's borderline. It's probably, I mean, it's doable. It just may not move as fast as it could. So I haven't decided if I'm keeping it yet. This is what one fully assembled the way they suggest you assemble it looks like.
Oh, okay. And
so this plastic thing is just, I guess, to keep kids' fingers from getting stuck. So it isn't necessary, but yeah. So, I mean, it's not bad for a cheap, smart servo. And it has the plastic pieces for mounting them together already.
So you can daisy chain them? Yes. Okay.
You need these little adapter plates to get them configured the way I want for the leg. You can't just directly connect them because they have these.
Find it in
Toys R Us, yeah.
Yeah. Well, $10. $10 was a good find because the smart servos are expensive.
I know, yeah. I mean, these aren't nearly as nice as like Dynamixels or something, but it does at least give you positional feedback.
That's enough. It's enough to. It was for that toy robot, and
yeah, they're add-ons for their other kits.
Yeah, it's at least enough to
And it's the
Make-
higher, apparently there's two versions of their smart servo, and this is the higher torque version. So that's, although I have not been, nobody's been able to figure out exactly what the torque is. Nobody's
It's,
Now, you
bothered
could,
to
you could
measure.
address each individually?
Yeah.
And save time? So you could do four.
Well, the way the packet is set up, you have to send out all four
Oh, okay.
all the time,
Okay.
whether that's full or not.
Oh, okay.
yeah.
So, yeah, I mean, depending on what you want to do, if you just want like a pan and tilt head or something, that'd be great. The update speed wouldn't be an issue.
Mm-hmm.
And for a lot of applications, it wouldn't be an issue. I mean, it's borderline for the legged robot, but one of the things I'm hoping,
That actually would be good for the thing that I wanted to do, my multi-antenna deal. Because it doesn't necessarily need to go fast. It just needs to go.
also, not that it matters much, but each one also has an RGB LED on it that's addressable.
Oh.
You can make it turn whatever color you want.
That's because it's a toy.
Yeah.
Neat.
I'm hoping that I might be able to reprogram the servos. I moved out here from California, but all my stuff would not fit on our moving truck. So all my shop stuff, including soldering irons and desoldering stuff and all that, is in a storage shed in California.
Ah.
So I haven't been able to do it yet, but I want to desolder the control board and see what the microprocessor is, which is underneath, of course, on the bottom side of the board from this point of view. But based on some of the pads they have here, there's a VPP, an SCK, and SDA. So I'm hoping
I2C?
it might be, yeah, it's I2C, and I'm hoping it might be reprogrammable. And maybe I could change the protocol and make it a little faster. But
Yeah, I see it. Need a magnifying glass.
I'm not sure what that 8-pin chip is. It might be a serial EEPROM, but I can't read. I haven't tried to really read the lettering. It's
Yeah, even in good light, it's hard to.
yeah.
I think it might be a shift register.
But anyway, so that's going to be. I'm hoping to go up to a friend of mine's in Middletown who's got all the tools I need and do the desoldering here in the next few days, and that'll determine whether I keep them or take them back. Well, the 10 I haven't opened yet. The 2 that I have opened, obviously, I'll be keeping. But
And when you got that, was it assembled at all?
no, it's a kit. You have to put it together, and you don't. I mean, like I said, this centerpiece you don't even need.
There's probably no soldering. It's just putting it together, right?
Oh yeah, no, it's just screwing it together, and it comes with the tool to
Just
do
screw
it.
together.
It uses I think they're metric. Yeah, it's a 2.5 inch hex, but it comes with a hex nut, a hex driver.
We can bring a soldering iron next time. I got a couple of soldering irons.
I think that's a shift register.
Might be.
I think it's a 74HC something or other. But
Well, it's got a decoder in there of some sort, so there's some sort of intelligence there.
Yeah, well, there's a processor underneath. I
Yeah.
can see it's a larger chip, but I can't until I desolder the motor from the board. I can't pull the board out.
see, I can't really see that. It's real hard to see the writing on that, but I thought I saw 74 something.
Again, I have a nice microscope, but it's in storage as well. So, but I believe my friend has one of those as well. So, I'll be able to decipher more when I go up there.
Yeah.
But yeah, anyway.
Yeah, you send me a note. You're getting a meeting announcement.
Mhm.
Yeah, if you're gonna be here next week, you want me to bring the soldering iron in to remind me? Bring soldering iron, solder?
Yeah, it should be done by then.
Oh, okay.
Just because you walked in afterwards, but these are I got some microwave devices, and there's basically no spec sheets on these things at all, like, period. And that one there, I believe, maybe Doppler, and if it is, I'm going to be able to do some pretty cool stuff, I hope. Vincenti's still not convinced. But these two, I think, were just meant as switches, as light switches. This one here, I'm not sure anything at all. But this is my goal, is to try to figure out what the heck these things actually will do.
I think that they are good for measuring movement.
Yeah.
But you don't know how fast it's very spread signal.
I know.
For a robot, something is there.
Right. Microwave version of a PIR.
Well,
Yeah,
that's what at least two of these are.
Yeah.
I know that, but I'm looking for the intermittent frequency off of them, because once you have that, you can do some other cool stuff.
You have laser.
Yeah.
Very pointy, narrow. Then ultrasonic, a little wider, and this one is 200 degrees of fire.
It's possibly pretty far. Yes.
You will find the drawings of the path. It's very wide. Something is happening somewhere there.
Well, I agree for at least the switches. The switches need to see everything.
Yeah, for to turn all lights and.
So we're going to play with them though.
We'll see.
We're going to try to figure these out.
Well, there is the image of this is the Arduino Nano sending the frame from the camera to the laptop, right?
Wow.
I made a graver image graver using processing in the laptop to capture each byte and transform in colors and draw very fast the screen. Okay, this is at this resolution there is a 1 megabyte of speed. Okay.
1 megabit throughput.
And you have 1
megabit throughput.
Yeah, 1 megabit.
Okay.
In the Arduino and also in the computer. This image is 1 every 3 seconds, 3 and something seconds. It's very slow. Then I change the resolution to go faster. I will load another program to the Arduino, another configuration of the sketch. The sketch has a different resolution here. I comment the frame one. Frame one is the message that starts all the bytes that come after the frame one describe one image. Okay. If I send frame two, in processing, I detect that there is another resolution, and I change the way of drawing the image. Okay. It's compiling. Usually Arduino is very slow compiling the first time. Maybe it's loading all the libraries and the compiler and everything. The sketch is very small. It's 5% of the capacity of the Arduino. Can you see here? It's very, very simple. No simple, but very small sketch. And now I'm sending a quarter of resolution, a quarter of size of the last image. Now we will have 1 frame per second.
Right.
Okay. This is faster than the last one.
Okay.
I move the camera.
Mm-hmm.
Here we are using the format I told you that, in the first presentation. There is the format that is RGB color, describe green, red, and blue. But this format is you send the grayscale luminosity of the image, and then you have 2 bytes describing the color of the pixel.
Okay.
But every 2 pixels share the same color information.
Okay.
And the human eye doesn't recognize the difference,
Mm-hmm.
but it's a way of shrink the data.
Mm-hmm.
Okay. This is a GUV format. Then I will show you the RGB format, but it's a RGB usually use 3 bytes, 1 for each color, right? But the format that this camera is using use 2 bytes to present the 3 colors. They use the first byte and the second one. Okay. They use 5 bits for the red, green, and they use 5 bits for the red. Okay.
Mm-hmm.
6 bits for green,
Mm-hmm.
and 5 bits for blue. You have colors with less resolution, but they appear very nice.
Okay.
Something that is happening in the low resolution in the other format is they for some reason change R for B. Just change the information, but it's not in the data sheet. They say nothing about that. Okay, now I will reduce again to half the size of the image,
Mm-hmm.
and we will have 3 frames per second.
Okay.
Let me download the stop this here. Go to Arduino Sketch, comment frame 2, and comment frame 4. Okay, this is an image of 80 by 60 pixels. Loading. Frank, how are you? Good. How's the weather side? It's getting cold? Yeah, it's not bad. Okay. I almost died in winter in Chicago. Okay, done uploading. Okay, this is the faster image I have till now. It's very slow. But I am planning to use the Arduino to do several things, okay? To identify colors and following the color. Arduino now is spending a lot of time sending the information to the computer, to the laptop. If you eliminate this part of the code, you have a lot of time to do other things or to increase the frame per second.
All right.
Okay. These three formats are made with the GUV codification of color. I told you it's no RGB. I need to have the RGB information because to identify colors, you need another space or representation of the color. Okay. RGB is used to translate to this to the other form of data.
Mm-hmm.
usually you want to find something that is green. Using this information, you think that, okay, green means that this area will be higher, right? But this doesn't happen really in this way of representing colors.
Mm-hmm.
This way is to control blue, green, and red colors that are how our eye works, receiving these three colors in different intensities.
Mm-hmm.
But it's very hard to describe the green using this format. You can say, okay, any value over 80 will be green. That's not true, because the other one changed the luminosity and they say S saturation, yes, and they alter everything. The shadow won't be green. The lighted part also is not detected as green. Then someone creates another way of describe colors, and they make something like a cylinder. This way of describe colors is represented by a cube. Each dimension is RGB, right? But the green color inside has a shape, very complex to identify an algorithm, right? Then someone translate this space to a cylinder, and now you can decide this area are greens, this area are yellows, blues, and you only use one variable, that is the first one. Is the new space is described by HSB. H is the hue, is the color. You only need this to specify the color, and then you have this to specify saturation, how much color, and this is to specify the luminosity of the color. And then you can identify a very wide spectrum of greens or reds, or okay. And the camera will be sending these three numbers. There is an algorithm to transform in these numbers, and then you ask if the H is between two values, if the S is between two values. Okay, if the algorithm recognizes that this is inside the area you are looking for. In my program, I changed the pixel for red. Okay, and you will see in the image, the first image I sent, I was changing for white, a bit white.
Mm-hmm.
Now I change for red to use the green bulb, and the bulb will translate to a red pixels, and see how it works. Okay, now those images were constructed using the format why something, the format YUV.
Yeah.
And then I made another sketch to work only with RGB to start identifying colors, right? Let me change the sketch. RGB streaming. Sender is the Arduino sketch. This camera is really tricky to use because it has, I don't know, 100 registers to control everything. A lot of it has automatic white balance, automatic gain, a lot of things, resolution, a lot of resolutions and combinations, matrix to to correct the distortion produced by lens. So it's very complex. It's very, there's a lot of information about it in the web, but many of them doesn't really works. A lot of people is experimenting with it, but doesn't really works.
Yeah.
The ones that are working are with faster microprocessors, like the Arduino Due, Arduino. The other one is the Due and
The
2650 or do or
the Mega,
Mega.
Megas-
Mega also works. And well,
the Yun would be.
my idea
faster.
was to use a very slow one, Arduino, the simplest one, to do the most ambitious thing, that is to follow objects, to identify colors and follow them. The idea is, for example, to make a robot. You show the ball, you tell him follow blue or follow green or follow, just talking maybe, or pressing a button, and you move the ball toward the robot, and he will go back, and you move the ball out from the robot, and he will follow the and I show you how it will be done. Okay, and let me load this sketch. And
invalid library.
we have
Oh, I get that all the time.
now this is all the definition of all the registers. A lot of registers. Many of them are very strange matrix coefficients for image correction. I don't even touch those numbers. Those are default numbers. Okay. I made additional definitions that I need, but scaling, and I'm still experimenting with changing the luminosity, the intensity, the contrast. You can change everything. It's very, very complete, but complex also. Okay, let's start with higher resolution and slow frame per second. Frame one, okay. Loading. Let me look for the. In processing, there is another sketch to capture the format, because now there is RGB, as I was talking.
How expensive is that camera?
$3 something. This is very, very.
Cheap.
Yeah.
It's in the price range.
It's affordable.
RGB. Okay. Here I have the description of each color. For example, I have uncommented the green color. You see the range of each part of the color: H low, H high, S low, S high, V low and V high, hue, saturation, and value of the color. Okay, and this is the color. Okay. Let's try to capture the. Okay, I need to change this. A second. Usually, serial port is.
It's snowing, okay.
It's right here. In my desktop, I have 5 serial ports. and it select the number 4. Here there is only one serial port. You must indicate which one is here. Okay.
There.
This is the automatic color balance. Okay. Usually, every camera you see, it has this automatic adjustment, but it needs several frames. And because this is very slow, you will see the adjustment very slow also. Okay. Now, you see, I don't know if it's possible to see the color. All those pixels
Okay.
are identified as green pixels. Okay.
Okay.
The yellow square is the sum of all the red pixels in the screen. The size of the square is the depending on the amount of pixels of red. Okay. And the position of the center of the square is the center of the centroid of all the red pixels. Is where the balance. The idea is to eliminate all the wrong pixels. There is green there, okay.
Now we got green walls, so this is one of our issues.
Maybe, but
Okay.
it's not good enough. But the idea is to correct the color,
Right.
to increase the frame, and to use the size of the
Where'd it go?
What's the frame rate now?
Oh, it's high resolution right now. There it is.
Okay. You move the ball.
So the top is probably looks white because it's so bright,
Yeah.
and the bottom you have a shadow at the
Shadow,
bottom,
yes.
so it's
You need a very good illumination to work
Cool.
with this. You see
it's got a
you see
reflection.
the reflection
Uh-huh.
in the table,
Yeah.
also red.
That's why that one camera I had was having problems with those
reflecting
colors.
off the
Yeah.
table. Oh,
The table looks.
The idea is to make this faster. Let me try with a smaller
resolution.
resolution
Yeah.
to go faster. Okay. Here the frame 4 is fast, but I need to exchange the red and blue. In processing, for some reason, at the resolution, the red and blue exchange position. I don't know why. I just made both.
So this is basically the same code, just running at a slower speed. The communication speed is the same speed, but you're just you're able to send less data,
Yeah.
or more frames, same amount of data, basically. But it's basically the same code. I got you.
I'm changing the recovering of blue and red. I exchanged both colors to have a more realistic image. Now will be several frames per second. Three frames per second. But there is a lot of artifacts in the image. You see the red, the vertical red
Yeah.
thing. Something is wrong there. But the idea is the robot will be identifying the color closer. It's a bigger square, and farther will be a smaller square. But at this distance, the red bar, the vertical red artifact is faking the estimation of the position. You know, I need to correct this. There's something about limits in the image. Something.
Looks like there's a green artifact too.
There's something going on over there. Interesting.
Without sending the image to the laptop, the frame rate will be faster, right?
Mm-hmm.
And maybe enough for a robot to follow.
Oh, okay.
And that's all being done on the Nano.
What?
The
all being
Nano's
done
doing
on the
everything. Yeah. That's pretty amazing.
That's cool. He'd get lots of reads off that article.
I will change the format. There is a Q. It is the VGA format. Q is a quarter of VGA. QQ is an 80 or 116 something, and QQQ will be this size. Okay, 3 times Q. But there is another format called CFI or CIF. And you can decide the size of vertical and horizontal as you wish.
Oh, okay.
I will try this format to try to avoid this problem with the border. I don't know what's going on. This doesn't happen in the other format, in the UV format. Doesn't happen this, but it's happening in the RGB format.
That's good.
But that's the idea.
That's getting good.
You can change the color for. There is the red. There is a problem with red. Usually, when the guy that decided to make this representation, okay, there is a 0 and 360 that represents the angle, okay? The red occupies this area, and you need to make two comparisons from 350 to 359, and from 0 to 20.
Same thing I have with
you
the
spend
compass.
double the time translating and comparing, okay? I made something that was to turn this representation 60 degrees to avoid us twice, okay? I will show you, now I will show you using the red color. Red color looks to be easy to use. I saw a lot of demos in internet for color identification. Almost everybody used the red color. Okay, this is the full red color. Comments, yes. There is a high range and low range red color. I create the full range color, but I have to do something with the translation, with the function that converts RGB to HSV.
Is that what they call, somebody calls that Maxwell's triangle? The three-dimensional thing that has intensity and
Yeah.
saturation and
Yeah.
and color.
Everyone is using this representation of is like a cone, inverted cone. The hue is in the breeze. The luminosity is the vertical dimension. The first thing I was thinking that RGB was the easy way to identify a color, but it wasn't. No one can use it for identify. You can identify exactly one color with three numbers, but not a range of different shades of green, or can identify exactly one color, but it's not useful for color identification. And look for the conversion. Here, I adding 60 degrees to the okay, ready. Now must be identifying red, I guess. I hope. You see the green ball? No, nothing's happened with the green ball, but something will happen with the red, right?
Okay.
And the robot will use this to follow the. You can move forward. If the square, the yellow square, go slower, go smaller, you move forward. And you need also a servo to change the. You move the color out of the okay, like this. The idea is that the robot can move in both directions, but the robot cannot follow the ball if you go up. Then you need a servo that the image vertically. Okay. There is a lot of problems, but I think I am on the way.
For close work, it should be very doable for close items.
Yeah.
For close work. Mm-hmm. When you're looking at a small confined area, that should work great.
The idea maybe to make a real robot and to test how it's working.
Mm-hmm.
But I need to correct a lot of things with the image, because these vertical things is not good.
Mm-hmm.
You can narrow the definition of red to follow this color more closely and avoid other
Mm-hmm.
pixels.
Narrow it down.
There is another thing that I'm planning to do is there is an algorithm that identifies lonely pixels. Okay, you review the image. If the pixel is alone or it's only with one pixel around here,
Mm-hmm.
you delete it.
Yeah, throw it away.
This is a way of cleaning a little bit the
okay.
Yes. But this reflection is bad because the algorithm doesn't remove this reflection.
Mm-hmm.
You know?
Now that's going to be a hard nut to crack there. You just need to say non-reflective surfaces. This is the same problem we have with some of the mice. Some of the mice, they don't work on reflective surfaces. They have that. You can see the LED light, and it's looking at transitions, but reflections, no.
Well, you have computer power. You can do a lot of things with the image. You know, there is a lot of algorithms, a lot of things to do with an image, but it's everything must be inside an Arduino.
But you're trying to do everything with nothing.
Yeah.
So
You need to put them in a jewel.
This square is very easy to make, you know.
Mhm.
You add all the pixels. Every red pixel is a unit. You add all the pixels, and you then estimate the square of this amount, and this is the size of the side of the square directly. Okay, and the position of the square, the center of the square, is the sum of all the distances of each pixel to the margin of the image. You sum all the distance, and you divide by the amount of pixels, and you will find the center of mass of the centroid of the image. And this can be done very fast while you are receiving the data. Just adding fast. It's very easy to do with the Arduino.
I think you could easily do a robot to follow it at that distance, to keep that distance there.
Yeah.
Should be easy to do as long as you don't try to do brown, like the tabletop color, or green the wall color.
Yeah, you need to control the colors of your
environment.
or use a special color, some kind of magenta or purple or something, and you narrow your. But will be affected also by the shadows.
Yeah, that's one thing. The color that you selected, you're using the same color at home, and it works?
Yeah.
Okay, and you have fluorescent lights, or are you using
No,
fluorescent?
I have the normal light.
Incandescent?
Yeah.
Okay.
It's working.
Well, see, that's hopeful there, because that's a pretty big variation. Your home light is much yellower.
Yeah, maybe to have several white LEDs, very intense LEDs, and you produce your own light to identify things.
Oh, that's true. Yeah.
And you control you go narrow to exactly the color you are wanting to follow, and in this way you disappear all the pixels
A
around.
UV light. UV material.
Can be also.
Of course, those the guys are probably bad with UV. That's true.
Well, this is how it's going. And
you could use a fluorescent green. Well, that's pretty fluorescent, and narrow it and use a very fluorescent green. That ought to do it. You don't see many fluorescent greens around.
The Pixie camera that I had though had a problem with fluorescent green against this green.
Really?
Until I had to train it
or...
again when it was here. You're looking at
Picture.
red right now.
It's seeing that brown as a red. Okay.
Kind of a red.
the other red is a reflection of red in the library.
Okay. It's taking it out pretty well, I must say.
Yeah.
Yeah.
That Pixie cam though had similar problems in here. I had to train it before we did the demo.
Is the flag in the corner?
Oh, okay.
There is also red in this picture. See?
Oh, yeah. It is picking them out.
The fire alarm. Yeah.
Oh, okay. You've got a wide range of red there.
You
Okay.
need to narrow it.
Uh-huh.
That's it.
Okay, looks good. Looks good.
Looks
Amazing.
promising.
So what's your longer term goal? I mean, you're working on it. Where do you want to go? What
I
magic do you
have a
want
lot
to
of
have?
other stuff and ideas working on.
Okay, so this
And
is just
I
one
come and
project
go.
of many.
If you can do a robot to do in a very confined environment, like right here, to find a green ball and bring the robot a fixed distance from the green ball and move the ball back and forth and have it follow the ball,
We can try it with
that would be, and one of the things I like to do is to have people have interest in what you're looking at. I think that would be very popular, and people would learn a lot from that.
Can we try blue? Nothing else but blue.
I like you can still see the blue ball. I mean,
Let's go
Yeah.
through.
surprised it.
Turns out so blue.
I need to comment. This is faking the function that translate RGB to HSB. You remember I add 60 degrees to make a single comparison. I correct that and go to looking for the blue, the comment in red. And blue. Let me green, blue. Now, supposedly,
Blue.
Oh, okay, the blue is red. Okay,
blue.
got it.
The blue is close to the red one.
And there's less blue around the area. Cool.
But it's a matter of timing.
Mm-hmm. Oh, yeah. He's got a light on his
Another
watch.
thing that
Yeah.
No, there is a black thing here.
Oh, there it is. Okay.
Cool.
It looks like it likes blue a lot.
The automatic color compensation is a problem
Oh,
with
here,
a robot.
because this is close to red.
Yeah.
And the red is the problem child in this room. The blue is excellent because we have a lot of blue. In
There's
there.
not a lot of blue in here.
But what about the flag? Can it detect the blue in the flag?
Another thing you can follow, for example,
The laser.
using only gray values, you can follow a laser light also. Okay. The brightest spot in the image
Oh, yeah.
is another algorithm you can use for a robot. Follow the laser. The brightest
Because
spot.
it's going to be brighter than anything. That is true. Wow, you got a weapon system there.
Yeah, you can use.
I mean, just mount the laser on a gun
To put in the center of the image
on something you can aim. Yeah. And then you could take that and the light and the servo, and it would, oh yeah.
I have a lot of ideas. There is a table, controlled by two servos. You can move in both directions.
Mm-hmm.
I use the camera above this thing. You paint in black, for example, the table, and you put a white or any color in the table, and you tell the Arduino to move the ball, moving around, go to some position, and the table just move the ball to the position. And
Oh,
stay.
okay, yeah.
You can do all kind of stuff with the image.
Mm-hmm.
I told you I bought a rain detector, something that captures water and measure the rain gauge, gauge in Lowe's. They sell the rain stuff. It's a plastic tube, transparent.
Yep.
Okay. I am planning to use a fan with a ball inside the tube. I move the ball.
Control the position of the ball.
Use the feedback with the image of the position of the ball in the image, and control the ball up and down.
Mm-hmm.
I'm working on that also to use the thing. There's a lot of stuff you can do with this.
The turret thing interested me. A turret is a gun mounted where you can point the gun and use the visual.
Pan until device.
Yeah.
With something.
Using the weapon as they had one that was automatic. It identified the object and would shoot at it.
Would be easy to do.
That vanished. Really, you can't find that. It's gone.
I'm working with the ultrasonic location, using the tweeters.
Yeah.
But I'm planning to use we have a new dog, and to create a virtual fence using two tweeters in the opposite sides of the house.
Mm-hmm.
And the color, in the color you have a device that sends RF signal, as I show you. You send the RF signal to the vehicles, and they send ultrasonic burst, each one, and you know exactly the position of the dog,
Oh,
and
okay.
decide if you produce a discharge using ultrasonic burst
Mm-hmm.
to know the position.
Something gets in the way, though. It would.
I will show, when I have this working, I will show here with a small robot. We put a tweeter in each corner, for example, and the robot will send RF signals to the beacons to send the ultrasonic burst, and calculating the time, you know, the distance.
Mm-hmm.
You have to, like, two circles intersecting in the robot.
Mm-hmm.
And he knows exactly where it is.
Yep. Okay.
This is working.
Got a lot of projects.
I got my Christmas present, my jewel from my son. So
Ah, good.
I sent you the new chip that is close to the 18 mega. It's like a nano.
Oh,
Arduino Nano.
yeah,
I already have it. It's working great.
okay,
It costs $2, right?
yeah. It was-
It's the
It's an
mega
Arduino
and the
Nano.
nano.
That costs $2.
Wow.
And you can select 3.3 volts or 5 volts.
Cool.
And it's faster than the
Nano.
18 mega. No, it's a replacement. It's a clone maybe, but they use faster register to register movements, and inside is faster at the same clock frequency. It produces faster results in
okay.
mathematics, and it has 10 bits, 12.
I thought,
10, 12, and 16 bits
I
of
thought it was-
resolution in the analog to
Oh,
digital
the
converters.
AD and D-Day.
Yes.
Okay.
And
I thought it was more
also
than
has
that.
Digital to analog converters, real one, no PWM, in the same chip, the same size,
Or a couple of
and
bucks.
it's working in the Arduino IDE.
Cool.
The chip costs 60 cents in thousands.
Mm-hmm.
You can use, you can make a commercial product with development in Arduino, and use the chip anywhere.
Cool.
But I am discovering things with the chip that is not good. It's not the linearity is very bad.
Oh,
You
okay.
know, the different values of voltage.
The
They
ADD is.
doesn't have proportional conversion values.
Oh, okay. It's non-linear. Okay. Yeah.
Let's see, but it's very, very cheap.
We'd have to linearize it, which, yeah.
But it depends. Each one has a different
Oh,
distortion.
each curve. Okay, yeah.
You cannot be calibrating every device. But can be used maybe in things that are where resolution are not important. No resolution, precision. The real value. This is. I made this comparison and made this drawing
It's a
to
nano
show
and
it's
a
exactly like
it's
the nano.
called a Mastuino.
Masterino nano.
Arduino. I bought 10 of them for $22.
Wow.
If anyone is interested, I can bring a sample to try. It's strange that the Atmel doesn't do something about copyright or something, because
The Arduino guys that's who they are. They're open source.
no, but I am talking about Atmel, the manufacturer of the microcontroller.
Mhm.
They copy the microcontroller.
The
chip.
The chip. Ah,
Yeah.
that's bad.
You know, well, we like it. We're just going to
Yeah.
rip it off.
Knock it off.
You know it.
Yeah.
But almost nobody talk about that There is a,
Your specs that you sent me say 16-bit,
system, but will be very slow.
but it's very slow. Yeah.
You are paying with the.
Normally, most analog people, if you're doing analog control, analog that is not that fast normally. The stuff you're doing like that needs the speed. Yeah. But if you're doing control, analog can be the slowest.
After I understand this camera, I am planning to use another chip from Atmel. Is the SAM 10. It's a ARM chip, very small and cheap also, but will be very fast. And it can capture DMA, the image, without the CPU intervention.
Wow.
Just using DMA,
Okay.
moving all the data to the RAM.
Yep.
And he tell the CPU, hey, data is ready, and you go and analyze the image and do whatever you want.
Yeah, what you're doing here, you're doing this with a Sauser. Seriously, you're doing with a. It's just amazing.
I'm pretty impressed.
Yeah.
You know, set you loose and see what you can do.
What's the number of that camera?
7670 OB 7670. In Amazon, you can buy it for $7. From China, $3 something.
It's in your meeting minutes. It's in the title. Oh yeah.
Frank doesn't read email. Can get those on eBay for.
Also, you can use, there is a rod with a ball that you can move with a servo and to control the position of the ball. You can paint everything in black and use a ping pong ball white, and use the camera to know where the ball is and move also.
So those are those.
To try PID controllers or something.
Sure. Yeah, you could get by with just a proportional only controller. Just multiply for that. That's pretty simple. But those sort of things would be very popular kits for our projects.
To demonstrate things.
Yeah, to demonstrate the Arduino. Engineers would be great for engineering.
Looks like the price of that camera went up.
It did.
It's a whopping $4.09.
Whoa! You told us $3.
It's moving.
That's on eBay.
Mine for $320 or something like that. But you can buy this camera. Also, they sell the plastic case, very small one, with a very strange connector, under $2. You can have you will find it there. You use the OB 7670. This one. How much?
$2.15.
Okay, it's a different connector, but it's the same chip.
It's the same
with lens
camera,
and everything. You can integrate to a robot using this connector in your printed circuit.
Make your own. Yeah.
But really, you can go down with the price. Look,
he's talking about.
This is the same camera.
Wow.
In a smaller package.
It's the same camera, but it's got the lead on it instead of.
You need to solder this connector in your board, in your own. But it also comes with the lens and the case. Almost under $2.
Yeah, if you're making your own products, then that's what you want to buy.
But you remember when we were working with the Laser Ranger? This is not good for the laser ranger because the size of the chip.
Right.
The chip is compared with the you need to use geometry for laser ranger, you know.
Oh, yeah.
And compare the chip I was using, comparing the size. This is the array I was using. The chip of the camera is the size. It's very small.
Mm.
And when you try to identify this distance, you will have a lot of problems because you touch the device and you move the temperature also will
Yeah.
change everything.
Mm-hmm.
You need a bigger assembly to have a real thing.
Cool.
Well, let's see. Next thing will be the Arduino will be doing everything. You won't see the image in the computer, but Arduino will send the size and the position of the yellow square.
Okay.
This is a very simple information, but you know that it really is following the ball, for example.
Yeah, you're not sending so much data down the pipe.
Just the coordinates of the square and the size of the square.
Mhm.
This is all.
Cool.
You also can integrate the nano to the camera in a case and use as a device for your robot. You ask for the position and the size, and this is all the sensor is sending to your robot. You will be using only position and size, and you decide what to do.
Okay. Let's see. Did you have something for next time, Frank? Was that?
I got my Echo also, so I will do the Echo because I had to buy stuff for the Jewel. I got on a power supply.
You're gonna do the Echo.
I'll do the Echo.
Okay, that's what we had scheduled for 1.5. Okay. And
Ideally, ideally what I would have it do is open my garage door. Open door one.
oh, okay.
How?
Alexa,
open
open door one.
How? Open pod bay doors.
So you're the voice recognition. Oh,
I can do something about voice recognition also with the nano, just the nano.
You know, this,
The numbers and several words.
The Echo is phenomenal. They have all those microphones in there. That makes a difference. Costs more than the Google Home. Google Home costs what, $130? It costs.
Oh, you got the big. You got the big
I
one.
got the big one.
Yeah.
It interfaces with more of the existing devices out there.
For now.
Yeah.
They
got a head start on it.
They definitely have a head start. Every couple of days, I get an email from Google that says, "We added this feature. Why don't you go and try this feature now?" Okay. I don't even own that light. Why do I care that you added this feature?
did you want to do a demo next week, Vicente?
I don't know what I send you
Okay.
information.
Okay. We want to do that too. It's good to put as much up there as we can. Right now, this is a light group, Christmas vacation, Christmas, New Year's. I suspect after the end of the year, things are going to get busy in here again. But these are good.
I received the IR temperature sensor.
Uh-huh.
I'm planning to attach a metal thing to detect with precision spot temperature. I will try to use it to scan some area and to represent the temperature of the area.
Of the area.
I plan to use, there is a connector, X connector, aluminum or something.
Okay.
It has threads inside, right? I will paint all in black and use it as a directional
Okay.
thing, to avoid any temperature that comes from the
From
the
anywhere
walls of
else.
this,
Yeah.
to detect exactly spot. I don't know if it works, but
I don't know if that would work either. But we've tried some other suggestions that didn't work either. So
then you can use it with the servos. Scan in an area and represent the temperature of.
Leroy was saying that he had trouble determining where it was looking, and
It's very, very wide.
but you put it in a tube though. You're focusing. You should limit what you can see, and
But you need a cold tube, a tube that doesn't have temperature.
the problem with the tube was it limited it too much. It made it too unsensitive
Maybe
too
you can
much.
use a small aluminum sheet in between them, both sides of them.
Well, what I had considered and I haven't done yet was cutting the tube in half and putting the tube on the outside, still having a wider thing in the middle.
a small tube. We tried a bigger tube. Try a super small, and this is easy to do. You just put the value up on the screen and put a small tube on it and see what it does. It's confusing. That is confusing.
It's to separate both.
I want the way I had it was the middle was where the buffer was. So the outside is what you want to block.
Both sides.
So if it's like this, you don't want to block this. You want to kind of block this, and you still want here in the middle. So you don't want to pick up the heat that's back here. Does that make sense?
But they have a very wide also sense.
Right.
And
But
they overlap here.
They do overlap. But what I found when it was in this tube was it wasn't sensitive at all. Even coming from the front, it wasn't very sensitive. So I thought you still need part of the front.
How fast do you have the data?
It's
How fast?
it's in the primary loop. It's just one thing in the loop. So it's
How fast you can get data from this device? Several per second.
yeah.
Depends on the loop.
Also, so.
Well, I don't know. I don't know what the best way is. It's working, but it's too sensitive. It's too sensitive, and putting it in a tube made it too not sensitive.
But try to use an aluminum
Yeah.
thing here, and you will see very different behavior. When you move here, you avoid this one to proceed here, and you move here, you avoid this one.
Yeah, I see what
better results.
More like a cone, like a dog collar.
Yeah, I kind of wanted the overlap, but I see what you're saying. I see why that might work a little better.
Right.
Maybe I don't know. See, I kind of put that up on the shelf because I got other things to mess with now.
I know.
Yeah. You know, too many things.
Many.
These are the.
I literally have more than 100 things waiting for.
Well, I just added 4 more things.
Because you buy the sensor, and okay, this is for this idea. in a drawer. Another sensor. This is for another day.
Or you
All the
buy,
time.
or you buy 10 433 megahertz things and decide, oh, that's not going to work. Now I have a bunch of 430. Anybody
I'm waiting, but what's
433
going on with
megahertz?
Frank,
this?
we got DirecTV down to 113. We started at 105 with what plus tax. 113 is pretty close. I may